In this video, we're going to complete the KutaSoftware Infinite Geometry free worksheet, Medians of Triangles Constructions. So, in numbers 1 and 2, we're going to construct the median from vertex A. Now remember, the median of a triangle goes from the vertex, which in this case we're always going to use vertex A, to the midpoint of the opposite side. So looking at number 1, here is vertex A, so the opposite side of A would be this side, and we need to find that midpoint because from the vertex to the midpoint of the opposite side, that is the median. And if you remember, in order to find the midpoint using constructions, we're going to find the perpendicular bisector. So on our compass, we'll go a little further than halfway, make a mark to one side of the line, then make a mark to the other side of the line that we're trying to find the perpendicular bisector of. Then switch endpoints. Go to the other endpoint of that line segment, keeping the same measurement on your compass, make another mark to one side of the line and another mark to the other side of the line, and those intersections will help you form your perpendicular bisector. Now the perpendicular bisector intersects at the midpoint of that segment that it bisects. So there is our midpoint. So now we just need to draw a line from the vertex A to the midpoint. And that line is our median. And number 2, locating vertex A, the side opposite A is this segment. Let's call it BC. So we're going to find the perpendicular bisector of segment BC. Starting with endpoint B, making sure our compass is slightly more than halfway, or slightly more than half the distance from B to C. We're going to make a mark to each side of that segment BC. Now off of endpoint C, we're going to make a mark from each side of that segment. Those intersections will form the perpendicular bisector. Now where that perpendicular bisector intersects BC, that is the midpoint, so we'll draw a line from the midpoint to A. And there's our median in number 2. In number 3 and 4, it says to locate the centroid of each triangle. The centroid is located at the intersection of medians. And in order to find the intersection of medians, we only need 2 medians to find that intersection. So let's call this triangle A, B, and C. We're going to find the median from vertex C and the median with vertex B. So that means we're going to find the perpendicular bisector of AC and AB. Starting with AC, we're going to make a mark to one side of that line from endpoint C and then to the other side. Keeping that same measurement, we're going to make a mark from A and then from A on the other side. Those intersections make the perpendicular bisector. And now we can draw a line from the midpoint of AC to vertex B, because remember the median is from the vertex to the midpoint of the opposite side. Now we'll find the perpendicular bisector of AB. Making our mark from endpoint A, and then making our mark from point B. Those intersections will form the perpendicular bisector of AB. So where that perpendicular bisector intersects AB, that's the midpoint. So now we'll draw a line from that midpoint to vertex C. And where those medians intersect, that is the centroid. So erasing some of these extraneous marks, you can see that our centroid is where those medians cross, which is this point. Now let's find the centroid for number 4. We'll have X, Y, and Z this time. So I'll find the median associated with vertex X and the median associated with vertex Z. So that means I'm going to be finding the perpendicular bisector of YZ in order to find that midpoint. So marking each side of that line with Y, keeping my compass the same measure, now going to Z and marking my 2 marks to find the intersections. Now that I have those intersections, I can create my perpendicular bisector. And where that intersects is the midpoint of YZ. And to create the median, I need to go from the vertex to the midpoint of the opposite side. So from X to that midpoint will be 1 median. Now I need to find the perpendicular bisector of YX in order to find the median associated with vertex Z. There are my 2 intersections that I formed using the endpoints and the same length on the compass. I'm going to mark my perpendicular bisector, and where that intersects XY is the midpoint, and I'll connect the midpoint to vertex Z. And where those medians intersect is my centroid. Continuing on to the second page, we're still going to be locating the centroid of each triangle, so we're still going to have to find at least 2 medians. So number 5, I'll call this triangle RST. I'll start by finding the perpendicular bisector of TS. So making my compass a little more than halfway, striking a mark above and below segment ST, and then going from endpoint S and striking that same distance mark. I'll find the intersection. The places where those marks intersect will help form my perpendicular bisector. Now remember, the median is from one vertex to the opposite midpoint. So if the midpoint of ST occurs here, that opposite vertex would be R, or that side is opposite vertex R. So there is 1 median. Now I'll find the bisector of RS. Creating that perpendicular bisector, I'll use the midpoint of RS and connect it to vertex T. Where those medians intersect is my centroid. And number 6, I'll call this triangle LMN. So I'm going to find the median associated with vertex N and vertex L. That means I'll have to find the midpoints of those opposite sides. So starting with side ML, I'll find that perpendicular bisector, which will help me find the midpoint. So connecting N to the midpoint of ML will give me 1 median. Now, finding the midpoint of NM will allow me to form the median with vertex L. Now creating my perpendicular bisector using those intersection of marks. My median of NM occurs at that point, and I'll connect that to vertex L. And where those medians intersect is my centroid. For numbers 7 and 8, it states that for each triangle, we're to construct all 3 medians to show that they are concurrent. And remember, concurrent means that they intersect at the same point. So it just wants us to draw every single median, and they will all connect at that centroid since they are concurrent. So for number 7, I'll start by labeling my triangle so that it's easier when I'm explaining the steps that I'm taking. I'm going to start by finding the median associated with vertex A, so I'm going to find the perpendicular bisector of BC in order to find that midpoint. And I'm going to be cleaning up my lines along the way so that it's easier to see. So finding this perpendicular bisector, where that intersects, this segment BC will be my midpoint. And I can connect that midpoint to vertex A with a straight line in order to create my first median. Now, for the median associated with vertex B. First, I have to find the midpoint of side AC. So once I find the midpoint of AC, I can connect that to vertex B, since the midpoint of AC is opposite vertex B. So there is my second median. So I know this is the centroid, the point in which they intersect. However, my directions state that I need to construct all three medians just to show that they are concurrent, meaning they're going to intersect at that same point, which is the centroid. My last median to construct is the one associated with vertex C. And in order to do that, I need to find the perpendicular bisector of AB to find that midpoint. So here is one intersection, and there is the other intersection. So I'll use those to create that perpendicular bisector, which in turn will help me locate that midpoint, and then from there I'll connect that with vertex C. And you can see that all three medians are indeed concurrent and intersect at that same point. The vertex was associated with A, B, and C all go through that same point, which is also the centroid. Now for number 8, I'm not going to label it, but I'm going to still talk through the steps. We'll start with this vertex at the top. That means we need to find the perpendicular bisector of this bottom side in order to find the midpoint. Making sure our compass is a little more than halfway between the endpoints of that segment, I'll make my marks from one endpoint and then from the other endpoint to find those intersections. Now, I'll connect those intersections to form my perpendicular bisector. And now that midpoint, I'll connect it with that vertex that's opposite. Now, I'll find the median associated with my vertex towards the bottom. So that opposite side is the larger side. So making sure my compass is a little more than half the distance between those 2 points, I'm going to make a mark above and below, then switch to the other end point, making a mark above and below. And you can see that I can just see my intersections. So connecting those to form my perpendicular bisector, I now have the median, which I can connect to that opposite vertex. And then the last median is associated with this vertex in the bottom right hand corner. So the side opposite that is this side, which we will now find the perpendicular bisector for. So I'll locate my first intersection, and then I'll find my second intersection. Now I'll connect the points that the intersections create to form that perpendicular bisector. Now that I have the midpoint of that side, I'll connect it to my vertex. And you can see that all three medians intersect at that same point and are therefore concurrent. And that wraps up the Medians of Triangles Constructions worksheet. If you have any questions, leave a comment below. And if you haven't done so already, like this video, subscribe to my channel, and share it with your peers.